Well, hi everyone. We have a semester exam practice. This is problems that we've done since that last test, since task 7. So we'll just start here with solving quadratic equations by completing the square. Now, on this one, I would go n squared minus 4n. I'm going to start over here. First thing I'm going to do is I'm going to get the constant on the other side. I'm going to add 98 to both sides. So I've got n squared minus 4n equals 98. And I left a blank here because I want to add the b over 2 squared. I want to complete the square. In this case, that b value is negative 4. So negative 4 over 2 squared is negative 2 squared, which is 4. I'm going to add 4 to both sides of the equation. And this number here, we've been kind of working with that lately, is what is going to be the binomial that's being squared, n minus 2 squared. If you were to multiply n minus 2 times n minus 2, you're going to get this, is equal to 102. So I am now going to, we're solving for n, so I'm going to take the square root of both sides. I'm going to write another step here. N minus 2 squared equals 102. I'm going to take the square root of both sides. And when I do that, I've got a positive and a negative square root. The square root and the square cancel. So that's n minus 2 equals plus or minus the square root of 102. 102, I'm going to look to see if we need to simplify. That's 51 times 2. 51 is 17 times 3. Okay, there's no simplifying we're going to get done there, so I'm just going to add 2 to both sides, and I've got n equals 2 plus or minus the square root of 102. And if I write them both out, it's 2 plus the square root of 102 and 2 minus the square root of 102. And the directions are the same here for this problem, so I'm going to add 56 to both sides. Okay, I'm working on this next problem here. I'm adding 56 to both sides. I've got x squared minus 10x equals 56. I'm going to complete the square with negative 10 over 2 squared, which is negative 5 squared, which is 25. So I'm going to add 25 here. I'm going to add 25 here. And this is the number that goes with the x inside with the square on the outside. So x minus 5 squared is equal to 81. And I'm going to take the square root, and I've got a positive and negative square root here. And x minus 5, square root of 81 is 9. So it equals plus or minus 9. So x equals, I'm going to add 5 to both sides. 5 plus or minus 9. And then 5 plus 9 is 14. And 5 minus 9 is negative 4. Okay. For each quadratic equation, fill in the blanks. So I got 4x squared minus 20x plus 25 equals 0. The value of the discriminant, that is b squared minus 4ac. So that's negative 20 squared minus 4 times 4 times 25. Negative 20 squared is 400. Now 4 times 25 is 100. Times 4 is 400. So 400 minus 400 is 0. And you can punch that in on your calculator, but the value of the discriminant is 0. When the value of the discriminant is 0, this implies that the quadratic equation has one rational solution. We've got one or two I'd fill in here. Rational, irrational, or imaginary is what I'd fill in here. Now I've got 2x squared minus 5x plus 67. The discriminant, which is b squared minus 4ac, that's going to be negative 5 squared minus 4 times 2 times 67. And that is, I'm going to calculate that one this time. Negative 5 squared minus 4 times 2 times 67 is negative 511. Now this implies the quadratic has two, okay, when the discriminant is negative, that's the part under the radical, has two imaginary solutions. So when you have a negative, you're going to have two imaginary solutions. Okay. This one. B squared minus 4ac. So I'm going to take negative 8 squared minus 4 times 3 times 4. And we're talking 64 minus 48, which is 16. So the discriminant is 16. This is a perfect square. That's important, because when it's a perfect square, this implies the quadratic equation has two rational solutions. In part D, b squared, 14 squared minus 4 times 1 times negative 38. Minus 4 times 1 times negative 38 is 348. I don't think that is a perfect square. I'll just take the square root of it real quick. And if it's not a whole number, it's not, then that is irrational. And that means that our quadratic equation is going to have two irrational solutions. Okay, so now we're going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. All of that over to a. So double negative 10, that's 10 plus or minus the square root of negative 10 squared minus 4 times a, which is 2, times c, which is 5, over 2 times 2. And that's 10 plus or minus the square root, that's 100. 4 times 2 is 8. And 8 times 5 is 40. 100 minus 40 is 60 over 2. I'm going to simplify the square root of 60 here. That is 2 times 30, 2's prime. That's 2 times 15, and that's 3 times 5. So the square root of 60 is 2 squared, square root of 2 squared times 3 times 5. The square root of 2 squared times the square root of 15. That's 2 radical 15. So we're looking at 10 plus or minus 2 radical 15 over 2, and I'm going to write that as 10 over 2 plus or minus 2 radical 15 over 2, and those 2's cancel, and 10 divided by 2 is 5. So 5 plus or minus the square root of 15 are my two solutions. 5 plus square root of 15 is one, 5 minus square root of 15 is the other. Those are the exact solutions. Okay, another quadratic formula. X equals negative b. I'm not going to say anymore. So I got negative 16 squared minus 4 times 7 over 2 times a, 2 times 4. And that's 16 plus or minus the square root of something. Let's see. Negative 16 squared minus 4 times 7. 144. Ooh, that is a perfect square. We're going to have two rational solutions. Just kind of go up with some of those previous problems. Because square root of 144 is 12. Okay? So I'm going to split that into 16 plus 12 over 8, which is 28 over 8, which is 7 over 2. You could have 3.5 or 3.5 if you want. 16 minus 12 over 8, that is 4 over 8, which is 1 over 2, or 1/2. So 7 over 2, 1 over 2. Those are my two solutions there. All right, number 6, another quadratic formula. Double negative b plus or minus the square root of b squared minus 4 times 1 times 2, 4 times a times c, all over 2a. So that's 2 plus or minus the square root of, that's 4, and that's 8. 4 times 1 times 2 is 8. 4 minus 8 is negative 4 over 2. Okay, let's do recall. Square root of negative 4. Square root of 4 is 2. Square root of negative 4 is 2i. So I got 2 over 2 plus or minus 2i over 2. That's 1 and that's 1. So that's 1 plus or minus I. Those cancel. 1 plus I, 1 minus I. Okay, number 7. The last thing we were doing. Converting quadratic equation to vertex form and give the coordinates of the vertex. The equation of the axis of symmetry and the direction of the opening. All right. So I got f of x equals, and I'm going to write 2 times x squared minus 4x plus something, plus 11. All right. I'm kind of getting it ready, prepping this for this. Remember these first two, let's factor the 2 out. For completing the square, I've got to have just x squared, so that's why I'm taking the 2 out of the x terms. And negative 4 over 2 squared, that is negative 2 squared, which is 4. So I'm going to add 4 here, and I'm going to subtract 2 times 4 here. I added 2 times 4 to the problem. I'm subtracting 2 times 4 over here to compensate. And then that is 2 times x minus 2 squared. That's the completing the square gives me that. 11 minus 8 is 3. So vertex is at 2, 3. The axis of symmetry is x equals 2, and it opens with that positive a value. It opens up. All right, number 8. let's do the same thing. The instructions are all the same. F of x equals 3 times x squared minus 2x plus, I'll just leave a blank there, minus 2. Okay. B, which is negative 2, over 2 squared. That is negative 1 squared, which is 1. I'm going to add 1 here. Now I'm adding 3 times 1, so I'm going to subtract 3 times 1 here. And that is 3 times x minus 1 squared. That's negative 2 minus 3, which is negative 5. Okay. So we have a vertex at 1, negative 5. We have an axis of symmetry of x equals 1, always this. And we have a opening. Those were both positive, so this one opens up also. All right, there we go.